In the Yukon, there's a river prospectors once swore ran with gold. They crossed mountains for it, they lost fingers to the cold for it, they built towns on the rumour of it. 100 years later, the same river is running orange, not gold, rust. It happened fast enough that the people studying it almost missed it. They'd set up their monitoring gear in 2019, expecting maybe 10 or 20 years before they'd see anything worth writing home about. The water turned within 2 or 3. Pyrite has been sitting under that ground since long before anyone was around to name it. Sealed in frozen rock, kept away from air and water by ice that wasn't supposed to move on a human timescale. This spring, in dozens of places at once, that seal opened. What's coming up isn't just colour, it's acid. It's zinc, nickel, aluminum, and concentrations that would shut a mine down if a company had put them there on purpose. Except no company did this. The ground did. To understand why, picture what permafrost actually is. Ground that stayed below freezing for 2 years or more, in some places for thousands, and the literal foundation everything else in the north is built on. Underneath a lot of it sits rock full of sulfide minerals, pyrite among them. As long as the permafrost held, that rock never touched liquid water or oxygen. No reaction could start. The cold did more than chill the rock, it sealed it shut. Warm the ground enough, for long enough, and water starts moving through soil that used to stay frozen all year. That ground is called a talc, ground that no longer refreezes in winter. Once a talc forms, water reaches the rock, and the seal breaks, sometimes in more than one way at once. From there, one version of the chemistry runs almost on its own. Sulfide meets oxygen and water, and the reaction generates sulfuric acid, the same reaction you'd get from an active mine, only without a mining company anywhere near it. The acid pulls metals out of the surrounding rock and carries them downstream. That's why the water turns rust orange and carries toxic concentrations of zinc and nickel along with it. The other version has nothing to do with sulfide at all. Microbes shift how iron moves through wet soil as the ground changes around them, and that water turns orange too, just without the same poison riding along inside it. Stand at the riverbank and you can't tell which one you're looking at. In parts of the Northwest Territories, the ground itself has started swallowing equipment set up to study it. The plan was to measure a few centimetres of thaw each year. What showed up instead was several metres of soil turning to slurry in a matter of days. For decades, the assumption was that permafrost thaw moves the way you'd expect ice to move. Slow, steady, predictable enough to plan around. By 2016, permafrost on 3 Arctic islands had already thawed to a depth nobody expected to see for another 60 or 70 years. That's not a rounding error in a model. That's the model missing the decade. Less than a fifth of the planet's permafrost is expected to thaw this way, in sudden collapses instead of slow retreat. That sliver of ground is on track to produce about half of all the carbon permafrost releases. A small fraction of the map is doing most of the damage, and nobody can point to that fraction until it's already happening. The danger was always real. The clock is what got missed. In Dawson City, a woman named Jackie Olson has spent her whole life in the same town her family has lived in for generations. She doesn't need a satellite to see what's happening to the ground underneath it, only the old buildings on her own street. Some of them are leaning now in ways they didn't used to. A doorframe can twist out of square over a few years, in a building that held its shape for a century before this. 20 years ago, there was almost no visible permafrost disturbance along the Dempster Highway, the road that connects this part of the Yukon to the rest of the world. Now there are stretches where you can see it for miles, ground that is slumped, cracked, dropped away. Every year, the people who've spent their working lives studying this exact stretch of ground gather in the same room to compare notes, and the last time they did, the room landed on one blunt line. Nothing like this has happened here in 14,000 years. Something else came up in that same room. The kind of knowledge people like Olsen carry, built from a lifetime of watching one specific piece of land, isn't something most Western scientific training treats as real evidence. The land had been talking. The instruments arrived late. Olsen isn't worried about convincing anyone the change is real. She's worried about what else is happening on land. No instrument has caught yet, because the only people paying close enough attention are the ones already living on top of it. The carbon that comes out of broken permafrost doesn't just sit in the air as a number on a chart. It traps heat. That heat warms the ground further, which breaks more locks, which releases more carbon. Nobody built this loop on purpose. It doesn't need anyone to keep it running once it starts. There's a second loop that's stranger and gets talked about less. The iron turning these streams orange doesn't stay in the Yukon. Rivers carry it to the ocean, the same way they carry everything else downstream. Out at sea, iron is often the one ingredient limiting how much plankton can grow, and plankton sits underneath almost every other link in the ocean's food chain. A process playing out in a handful of unnamed creeks is already changing how much iron reaches saltwater in ways nobody has mapped yet. 2 loops are running now, started by the same opened seal. One feeds the warming that caused it in the first place. The other feeds an ocean 1,000 miles from anyone watching it happen. Back in Dawson City, Jackie Olsen still walks past those leaning buildings most days. She isn't waiting for a research team to confirm what her own eyes have already told her. No one is going to tell you how many other seals like this one have already broken. That number doesn't exist yet. Most of what's been found so far turned up almost by accident. A research team standing in the one creek bed where it happened to be visible. A satellite analyst who noticed a single pixel change colour. But the first sign of this never came from a satellite or a sensor. It came from a woman noticing her own door frame had stopped sitting square. Long before there was a number for what's happening under Canada this spring, there was someone standing close enough to it to feel it happen. That's the part worth remembering once the cameras and the researchers move on. The ground doesn't wait for permission to change, and neither does the person standing on it. Olsen already knew. The rest of us are just catching up.